there.
We're now live.
Oh, they're live. Oh, cool. Okay, well, welcome. My name's Corey Hulen. I'm going to give a brown bag overview about Mattermost architecture. So let me go ahead and share my screen. Go ahead and get started. All right, so you guys see that okay? I just want to be able to have multiple screens.
Yep.
Or multiple tabs. Cool. So this is just an architectural overview. We're going to talk a little bit about sort of the way the system lays out, the different services, maybe a little bit of the directory structure and some of the code. So let's go ahead and get started. So a high level, here's a network diagram, just really high level. Can you guys see my mouse or no? No, huh?
No.
How about now? No?
No, I don't think Google Hangouts shows the mouse.
That sucks. Okay. Oh, that's all right. Let's go back. I'll just talk through this real quick. Basically, starting from the left, we have the internet. Obviously, we have a couple of clients that connect. The two that we provide are the web experience and a mobile experience. We both have a mobile app experience, a mobile native app, and a mobile web app. So those obviously talk to the internet. They talk to typically a proxy. That proxy in our case is almost always Nginx. That Nginx proxy going to the right then talks to our Mattermost server. Our Mattermost server is just a self-contained binary. Our Mattermost server then talks to a database, a SQL database, and we also talk to file storage, which could be local storage or something like S3 or Minio. So I'll kind of go into more detail about these things through the slides, but this is just a really high level. There's a couple other random services around, like push notifications, sending emails out, LDAP integration. But at a really high level, we're a simple architecture. We have a client, typically a web client, that talks to a proxy, typically Nginx, that talks to an app server, the Mattermost server, that then stores stuff in a SQL database. And that's at the kind of the root of the core of the system. So Mattermost proxy layer, there's different types that we support. The main one that we do is Nginx. We also support hardware load balancers and stuff like Amazon Elastic Load Balancers. We have heard from the community of people running Apache successfully as well as a proxy. And so the next question is kind of why it's needed. We use it for a lot of different reasons, but probably some of the highlights are right here, which is we use it for TLS or SSL termination. We use it for access logs, so you can easily record access logs and process those logs using standard tools. We use it so we can easily map or bind to ports lower than 1,000, so mainly port 80 and port 443. We also do use it for caching, so you can cache static files there. And then in high availability mode, we also use it for things like load balancing. Now, some of the cool stuff that we're actually introducing into the product is we're starting to remove the need for this for simple installs. In our 3.5 release, we integrated Let's Encrypt. So now we natively support things like SSL termination at our server itself. And we're slowly adding some of these other features. And so our recommendation is if you just want a very simple setup, you don't even need the proxy layer anymore. You can just run against the Mattermost server directly. And we'll probably be adding more and more features in that direction as time goes on. So it makes things like setting up for small teams, super quick, super easy. You basically need, a Mattermost binary, which is the server, and a SQL database, and you're ready to rock and roll. So that's a high level about the proxy layer. Quickly about the database layer. Our database layer today is SQL. The types that we support are MySQL, Postgres, Amazon Aurora, which is just a MySQL variant. We support the current version and one version back. That's not to say it doesn't run on older versions. That's just what we support. We do know people do run it on older versions and have had success. So the next question kind of is why SQL? And for us, it was a conscious choice over NoSQL. And some of those reasons are it's simple. Everyone understands it, or everyone knows SQL. Most people have resources at a company who know SQL. There's standard tools for administering SQL. And for us, one of the, even me personally, as much as I love some of the NoSQL stuff like Cassandra, not everyone not everyone is a hipster or has access to all this cool latest and greatest technology. And one of the things that we focus on at Mattermost is being on-prem or in your private cloud. And so by saying that, you're kind of limiting yourself to sort of the biggest, broadest access. And for us, that's SQL. And then kind of the other kind of interesting point is, it's easy to own your own data when it's in standard tools. It's easy to export to database. It's easy to snapshot it. It's easy to take it from point A to point B. And if for people who are curious, they can go kind of read how Mattermost, the company, was formed. But that was one of our biggest gripes about other systems is it's our data. We're the ones who entered it, and we can't easily get it out of any system in any kind of standard format. And it was super frustrating to us. It's data we own. It's our, it's sort of our IP, and there's no access to it. And so for us, doing this in a SQL layer, because of its simplicity, its ease of use, its standard tools, just made a lot of sense. And we're really focused on team's size that is small when you compare it to internet size scale. Like, most teams are between 50 and 5,000 users, and a team of a couple 100,000 users would be considered extremely large, like one of the largest. And so that's where our really focus is. And so we don't need a system that manages millions and millions of systems or teams or whatever. And so that easeability is one of the reasons for choosing this. We do support a lot of interesting scenarios from the database layer. We support things like read replicas that's built natively into the product. We also support obviously things like SQL clustering, so you can scale these solutions out pretty extensively. And we'll probably maybe talk a little bit about that later. So that's really quick on the database layer. Mattermost server. So the source code's there. We'll probably poke around in a little bit. The Mattermost server is written in Go, and sort of why Go? We get this question a lot, and I think sort of the main reasons are it's simple to understand, simple to implement. It's type safe, which is a big thing for, at least for me personally. Like, there's certain languages that I love. Like, I think Python's a great hacker's language, but if you've ever tried to maintain 1 million lines of Python or find a bug in 1 million lines of Python, like, it's not easy. Like, yeah, I know there's a lot of ways to do it. There's a lot of tools that help you, but in my mind, it's very different than having a type safe compiled language. And then for us, the other kind of interesting thing is the compiled executable, the single executable. So this really translates into compile time headaches versus runtime headaches. And it shifts the focus from the user to the developer. And for us, this is a really big deal because, remember, our goal is on-prem or private cloud. We don't want people having to worry about how to configure the system. Do you have to install this version of some virtual machine or this version of Python or who knows what? And all those things create a lot of headaches for users, for end users. And so for us, part of that is shifting that headache to us, the developer, instead of the user. And so that's kind of a big thing. And that's sort of why Go at a high level. Now, there's other really cool things, Go routines, Go channels that make it a lot easier. But the reality is it's a very simple sort of C-based language that anyone in the community can pick up and understand. And so for us, those are some of the reasons why we chose it. So the server is mostly stateless. I'll go into some of the reasons or the areas where it's not. But for the most part, we try to stay stateless. The reason for that is so that we can do things like high availability and you can have multiple servers. There is some state that is stored in the app layer itself, and we'll kind of get into that a little bit detail. The first state is obviously just some caching for performance. You know, we've talked about, and in fact, one of our previous incarnations even had Redis as a caching mechanism. But for us, the complexity of having that extra service didn't necessarily justify, or its complexity of having it didn't necessarily justify having it in the product. And most of the caching we do is in the app layer itself. And so there's a little bit of state there. Now it's ephemeral state in the sense that if the server restarts, it just reloads it from the database. So it always has it. If the server crashes, it doesn't matter. It can always rebuild it or re-get it. So that's kind of ephemeral. We don't really care about that kind of state. The other state that's more important is actually the WebSocket connections, and that's the only place where we really have state. And we'll go into a little more detail, but basically we use WebSocket connections for notifications. So if we're basically pushing from the server to the client is where we use it. And we'll kind of talk a little bit more about how we use that or why we use that. And those are really our only two areas of state in the server. What is the server? The server is basically a RESTful JSON web service. You can go look at our APIs. All of our endpoints are there. We're in the, a lot of the most important ones are well documented. We're in the process of getting a lot better documentation there. But one of the key or interesting things is anything you see the web app doing or the mobile apps doing is being done through this web service. So sort of 100% of the functionality you see happening, occurring in the product, the end product that people use, is happening through this RESTful JSON web service. And we'll kind of talk about that, go into a little more detail. We provide a couple different drivers. The first one we'll talk about is the Golang driver. And we use the Golang driver for things like bots. We also use it for things like all of our unit tests. So let me go ahead and show you a little bit of that. I just want to go into some different examples. So if you're looking at our source tree, let me back up one level. Here's the platform repo. Platform is the main repo where the server exists. It's also where the web app exists. We'll kind of talk through a bunch of this high-level directory structure. In fact, let me do that really quick. APIs is where the RESTful JSON web service sits, all the endpoints. I'm going to skip over stuff that's not that important. Config is where our configuration file sits. I18in is where our localization sits. The model is our model or our object model. I'll talk a lot more about that. We'll kind of dig into that next. That's also where that's what we refer to as our Go driver. There's the store, where basically our object relational mapping layer, some templates, tests, utils, vendors is just the Go third-party packages. And then web app is the big one. So this is where our React web app sits, and we'll kind of go into that into some further detail. So let me just start with the model. So the model is basically it's our Golang driver and object model for the entire system. So probably one of the easiest, or not easiest, but interesting to look at is something like user. If you look, it's basically a user struct. There's a bunch of properties. We have things like it all fully converts bidirectional to and from JSON, and pretty much all of these types or all these structs in this directory, a lot of them have a one-to-one mapping to an actual database table. Most of them do, at least. And so if we look at user, we'll see things like an ID, which is the ID, a column in the table, create date, update at, all that kind of stuff. Then you'll usually see a bunch of helper methods like is it valid, some pre-save stuff, some to and from JSON. So just a bunch of helper methods on that object itself. And the way that those objects are used is we basically have what we call client.go. So this is what we call our client driver. And if we search for stuff like update user, you'll kind of get an idea how it's used. So you can call update user, you pass it in a user, it's going to return a result or an error. In this case, we're just posting to this endpoint /user/update, and you can kind of see how simple it is. We're just taking that user object, serializing it as the post body as JSON, and then submitting it. And so we're either getting back an error or we're getting back an actual user from the system. So we're reading back out of the body in the response, and we're deserializing the user back out of that body. And that's how most of these are if you look through here. And we'll kind of go in a little bit more detail, I think, as we get into the web stuff. But that's really high level. It's the Golang driver, and like I said, there's 100% functionality in the sense that every endpoint in the system is mapped here in this client.glow file for people to use. So that's our Golang driver, our database layer. Let me talk a little bit about that, and then we'll kind of click into the code and go through it as well. We basically use SQL for storage. It is sort of designed with interfaces, and it's designed, the original designer intent, it was originally designed to be able to easily replace that with different types of storage backends, even potentially, NoSQL or a backend. There's a very simple object relational model, but it's pretty much one-to-one mapping, and we try to keep it very simple for the most part. One of the other things we try very hard to do is the server upgrades the schema from release to release, and so there's code in there that's basically smart enough to figure out what version of the schema you're on, what it has to do to upgrade, and it executes that code when it detects that you've upgraded the system. But so really quick, let me kind of click into here and describe sort of the store. If you look really high level, there's store.go. You can see these are all our interfaces. These pretty much, like I said, correspond one-to-one to a table in the database. So if you look, there's user store. We can look at update again, and we'll kind of go poke through that really quick just to see what's happening there. And so this is the interface. If you look at the implementation of the interface for the SQL, it's for SQL at least. And for SQL, we do both Postgres and MySQL in the same code base, since it has so much shared code. Every once in a while, you'll see some if-else statements like do this for Postgres or do this for MySQL. But for the most part, that's really rare. So if I go look at like the SQL store, I can probably look for update, what's this update? Or let's look at save. I just update user. So here's kind of a quick high level how update works, basically, or how a function in the store works. So here's an example, Mia, where I want to call update user. I'm just going to call update user. I'm going to pass in the user model. It basically immediately returns in a Go function, and it returns what we call a store channel. And so this is basically everything in the SQL stores. I think everything for the most part is basically asynchronous. And if you look, they're pretty simple. Basically, here it's going to do some pre-update, might run some validation, and then basically it's going to, down here a little ways, it's basically just going to call update. So it's going to pass that user in. In this example, we use GORP as our object model, object relational mapping system, and it's just taking our Go object and it's just saving it to the database. There's other cases where, like here's update last picture at, where we'll call some SQL, pass them some SQL, but it's pretty standard stuff. It's nothing super fancy or super crazy. The only difference is it gets a result. It may or may not get a result. If it does, it just passes that result back down the channel and then closes the channel. So that way everything happens asynchronously, and the caller can choose how they want to block or what they want to do. So that's kind of really quick. If you look, at most of this stuff is very similar in here, and you can kind of look through it and see how the database persistence layer works, basically. Server upgrade. Oh, really quick. Like I said, we do server upgrades. So if you look at SQL upgrade.go, There's a lot of logic in figuring out what current version you're on, what the next version is, and the system knows how to upgrade itself from one version to the next. And so, like I said, just worth mentioning or whatever. That's the database layer. So API layer. So we'll talk through some of the endpoints. One of the things we're trying to do is moving more towards an app layer here. So the API layer is basically the endpoints. There's not a great abstraction internally of an app layer per se. We're starting to do that in places, and we have plans to do that a lot more. So let's go look at an example of that. So once again, I'm in platform API. These are all the APIs. So if we go like back to user, we'll see here's user. We can kind of see really quick, like, okay, here's all the endpoints for this user, for users or user object. We can actually go look at update user really quick and kind of see what it's doing. Basically, it's deserializing a user out of the request body. It might be checking some permissions or some validity. Then it's just basically calling the store to update the user. And if that's successful, it might do some auditing. It might send some emails. And then it eventually sanitizes the data and basically returns it back on the API call. And so you can see here, this is just, we add our own context, but this is just basically a request handler. So this is one where it takes a response writer and a request, but you can see from things like create user. So there's create user, which is kind of the same thing, takes a response and request. But then there's also an example of what we call like an app layer API of here's create user, where I don't actually have a response and request, but I just want to call this from internally from the code. I just pass in the user object. It's going to pass out the user object back out, and an error, an app error if it occurred. So that's kind of high level about the APIs. You can kind of look through here. All the endpoints are here. And they're all, like I said, they're almost one-to-one correspond to sort of the endpoint itself. So if you notice, there's a command space handler, so create update list, and that's all in command.go. And so they all kind of follow that same pattern. So if you want to go make modifications or go fix bugs or who knows what, it's a place to start at least. So that's API. WebSocket. So let me talk about the WebSocket. So we basically have two forms of communication with the server. We have, HTTP RESTful JSON web service, and then we also have WebSocket connections. Each browser tab or native app basically creates a WebSocket connection. We use that connection for sending messages from the server to the client. So it's basically used for notifications. So we do a lot of things on it. We do like broadcast messages like, Corey is typing or someone is typing. We also notify the client when they need to update. So things like, hey, a user was added, a channel was added. In the original design, we weren't relying on this very heavily for passing actual data. We would just pass messages, and the clients would be responsible for fetching the data. We're slowly moving away from that. We're kind of 100% dependent on the WebSocket connection now, where it actually does, for performance reasons, we just pass the data right back down the WebSocket connection. So a great example is when you create a new post, you'll post the information, it'll get saved into the system, into the storage, and then we'll immediately pump the message back out the WebSocket for all the clients who are actively listening to update their views right in place. And so we're depending on it a lot more for stuff like that. So basically, in theory, each browser tab has the potential for two connections, or the WebSocket connection, and then I guess more than two, but any other kind of HTTP connections that normally get made. But there's always a WebSocket connected, basically. So some of the interesting stuff we do, all the web clients or all the clients are written in such a way that when they detect a WebSocket disconnect, when they reconnect, the first thing they do is kind of resync everything or ask the server like, hey, I disconnected, give me everything I think I'm missing from this point or based on this information. And so we try to make that pretty resilient, where if the clients sort of disconnect, they'll kind of reconnect and sync up where they need to be. And so you'll notice that sometimes where the typing box may go yellow, that means it's actually disconnected from the WebSocket. And then after enough time, you'll actually get a sort of a blue bar saying like, hey, we can't actually contact the server anymore. But as soon as the server comes back up and the web connection is reestablished, the WebSocket connection is reestablished, it all goes kind of back to normal and starts working again. That's kind of high level about the sockets. Some other stuff interesting to talk about: file storage. So we use file storage for when you upload files onto a post. That could be any type of file, but also images as well. Images for us is kind of a special case because we do some extra work in that case. But we basically support local storage, or basically writing to a directory. It's great for very simple single server installs. We also support things like NAS storage, and then we also support sort of cloud storage things like Minio or even Amazon S3 for storing files. And that works great when you have sort of a high availability mode where you have multiple servers and you want to write those files all to the same location. For images, we do a little bit extra work. We basically convert and store a thumbnail and a preview of the image. And that's to make sort of the web UI or the UIs be able to render a small thumbnail without downloading a whole lot of content, render a preview without downloading a whole lot of content. And then you can actually download the original file, which could be several megs, up to whatever you kind of set the upper limit as. Configuration file and the admin console. So really quick, we have let me just go through that. We have a configuration file. If you look, that's basically in config, config.json. So here's everything you can kind of change in the file. There's great documentation out on the docs website explaining what each of these properties are. But even better than that, there's a system console that modifies all this stuff. So you don't have to look at this or understand this if you don't want to. You can pretty much, I think, modify 100% of this file from the system admin console. And there's great documentation in the system admin console about what each of these settings do. And it kind of saves you from mucking with this file and maybe accidentally shooting yourself in the foot by changing something you shouldn't have changed. So that's just a quick heads up about the config file. That's the configuration file. Okay, so onto the web app. We'll look at the source code here in a second. Sort of why React? I think when we started this project a long time ago, React was kind of new, but I think there was some really interesting things we saw in it. I think we really liked its model, especially compared to all the other frameworks out there. I don't think anyone's like I don't think there's no love lost on JavaScript and frameworks. I think everyone's dealt with one some point in their life, and in my mind, they're all kind of equally crappy. But React is by far the best one, and I think that's more a function of the language and the way it's used than anything in terms of versus the framework. But there's a lot of interesting thing about React, and it's the way it does stuff, and its performance with how it modifies the virtual DOM and then stores it into the real DOM, and it makes that architecture of doing that, as well as the way they componentize things, at least in my mind, kind of a really nice layout compared to older frameworks or other frameworks, I guess is a better way to say it. Some of the interesting things we've done over time, we're a single page app using React Router. That's something we've introduced over time. So actually, let me back up really quick. Actually, I'll talk about it in the Fluxus. Okay, so sorry. Yeah, single page app. So we moved to React Router several releases ago. And that makes it really nice for a lot of certain things, but it gives us the ability to sort of cache a lot of the JavaScript as well. We have a JavaScript driver. It's very similar to the Go driver in the sense that it's 100% sort of full fidelity. Whatever you see, and if you look at the code, you'll see it. Whatever you see the web app doing, it's actually doing it through that driver. So 100% of the functionality, what you see in the UI, is 100% done just talking RESTful JSON web service to the server. I like to say we're Flux-ish, and this is for a lot of reasons, but probably the biggest one is we do come from a little bit of a legacy app that was written originally in JavaScript and HTML, just using jQuery back in the day, and so we moved to React kind of before Flux was a thing. And even now that Flux is a thing, I like to say we're Flux-ish in that we've kind of slowly gone that way and introduced a lot of the sort of the Flux architecture or model. And then one of our long-term goals is to move to Redux, and hopefully there'll be a future brown bag about that. But we've been doing a lot of work in Redux lately with our React Native app, and I think the consensus is we really like it, really like the model, we really like how it works. And our hope is long-term to start reintroducing that back into our web app. So really quick, we can go through some of this. Actually, let me just click into the driver real quick so people get an idea. We maintain a separate repo for this. There's Mattermost JavaScript driver. This is basically the driver that we use. You can npm install it. There's some examples on how to go use it, and like I said, this is the code that the web app actually uses. So without further ado, let's go ahead and so we'll talk about actions real quick. So actually, let me back up and give an overview. So if you remember, we're here in the platform directory. Within that platform directory, there is the web app directory, and it's a pretty beefy directory because this is where our entire web app sits. And so let's just really quick go through this. We have actions at the top, so these are actions. We have components or views, so this is where where all of the rendering gets done basically. We have some configuration. I'm going to skip over stuff that's not that important. I18ins for localization. Images. We have routes for our React router. Sass for our CSS or theming is all in this directory. Our stores, so these are our Flux style stores. We'll talk a little bit about that. A bunch of our unit tests sit in here as well, and then some utility stuff. And so really quick, like if we go to actions, we can probably pick one like channel action. I'm going to try to find, like I said, these aren't necessarily all standard, but they all kind of follow some kind of pattern. And let me try to find a decent one. Remove from channel. Sorry, give me a second. Or I guess maybe open. Remove user from channel. So here we're calling. We're actually calling the client JavaScript driver. It's just like once again talking RESTful JSON web services to the server. When it comes back from the server, it's doing a couple different things usually. It may be saving stuff into the store, emitting stuff. Sometimes we do stuff through this async client as well. So this is async client dispatching an error message basically. And you'll see the async client used in other places like right here. And so we're trying to get this a little bit cleaned up, but async client is something that, in fact, let's look at async client real quick. That's probably a better example. I guess utils, yeah. And so if we go look at async client, we can kind of see how this, like here's get channels. So this is probably a better example. So here's us getting channels. Here you can see it calling the JavaScript driver. When it gets data back from that call, it basically dispatches an action. So here's an example of it dispatching an action, which is, you receive the channels or receive the users. It's passing that data along. And the stores, this is basically dispatching an action to the stores. And so the stores will save this information and give it back to basically the web app. In the error case, lots of times we're just calling dispatch error, which will try to do a little bit of error collection as well as display a message to the user that an error has occurred. So that's really quick. Actions, stores. Let's go look at the stores really quick. So at a high level, there's stores. If you look, they're not quite one-to-one, but they're pretty close. So like here's user store. And if you remember, like if you go to the bottom, you can usually see the dispatcher, and you can kind of see all the actions that this store will handle. So there's one for receiving profiles. It basically saves the profiles in the store. might do some other random stuff, and then it basically emits a change. So any kind of React component listening on this store will receive like, hey, something has changed, go update yourself. And if you look, the store is just basically saving objects or whatever into itself. And so that's kind of high-level store. Let's see what else. Components, yes. Let's go pick a component to look at. So really quick, a store emits a change. A component is usually listening to a store. So let's try to pick one. Claims. So here's an example. Is this one listening to a store? Did I pick a bad example? Nope, that's just being passed in. Maybe admin console. Let's see. No, that's a bad example too. Sorry, give me a second. Create team. It's probably not listening to a store, is it? Give me a second. I'll find one backstage. Is it in the controller? Oh, here we go. Like on team change, right? Nope. Nope. Never mind. Component demand, add change listener. Yeah, on team. So here's an example. Sorry, where backstage controller is listening to the team store. On the component did mount, it basically says, hey, I need to listen to changes in the team store. And then on the unmount, it'll remove that from the change. Basically, what happens is when something changes in this team store, this updates the state. Updating the state causes the React component to re-render. And so this is kind of the old way of doing it. Like I said, in our React Native, we're moving more towards Redux, and sort of a lot of this stuff is kind of changing. But it's just kind of really quick, high level of components. Let me actually talk about component directory structure real quick. So if you look in components real quick, you can kind of see a lot of the high level components or routes, like admin console. So there's all the admin console pages. You can come in here and see, like, admin settings page, the audits page. We're trying to clean this up as well. So if you look at a lot of the newer structures are like this, where they'll have a components directory where here it's all the components, and then you'll have an actual controller that controls those components. So that's kind of high level, the web app components directory. So this is basically where all the React components sit, and all the things that actually render to HTML sit in here. So that's web app. Really quick localization. I think we support, 10 plus languages now, 11 plus languages now. So we've done a lot of work in that area. That'll probably be a future brand bag, but I just wanted to hit on it real quick. There's localization files that localization gets added into, and there's a whole framework for doing this, but you can come in here and see like all the English translations, and you can search through the code base where those things are. So there's both translations that happen on the client side. There's both translations that happen on the server side. There is a server language, and then each individual client or user can set their own client language, and we support all those different cases. So that's really quick. Localization styles I'm not going to talk about. Okay, other stuff worth mentioning. So I'll probably spend 10 seconds, 20 seconds on each of these topics, and they're probably good topics for future brown bag. Push proxy, what is it? Basically, we host a push proxy service where the Mattermost server will send a message to a push proxy. The push proxy will then send the message to Apple or Google, and then Apple or Google will then actually push a notification to your phone. So it's used in the case where you want to push notifications to a phone. The reason it's done like this is because we host apps in the App Store for Mattermost, and those are sort of linked to our account, and so they have to be pushed through our account. And so we give customers and users an option for pushing notifications through us. Or you can host it all yourself. You can spin up your own push proxy, run it behind your own sort of on-prem firewall, and release your own apps into the App Store. Really quick, mobile apps. The current mobile apps are shims. They're wrappers around the web view. We have some bunch of cool new stuff coming. We're doing a lot of work around React Native, so I think that's probably a great topic for a future brown bag. We do have a desktop app. It's Electron based. Once again, a good topic for a future brown bag. We have the load test or the load test repository. So we've been doing a lot of work in the last couple of releases around load tests, around performance. And so we have a bunch of great, pretty extensive framework about loading the system up with users, running load tests, and watching that and making modifications based on that. And then last but not least, we have Docker. We have two different types of Docker. We have what we call a Docker preview, which is basically everything in one box. It's great for just getting up and running quickly. And then we also have Docker Compose, which is it's broken out into its 3 different boxes, kind of more production-ish style. I think we still find a lot of people installing, sort of on Metal or in their own cloud by just downloading our binary and going through our setup instructions. So that's another way to do it, and probably the most popular. So other stuff worth mentioning. Oh, environments. I think this is always fun to talk about. This is more like a straw poll. Like I just, based on the people I know in the team and what different people use. It's always interesting to talk about. Developers, I think the majority of us run Mac machines. I think there's a few Linux holdouts, Arch Linux or Ubuntu Linux for development. But the majority run Mac. I don't think anyone develops on Windows, at least nobody in the core team or core committers that I can think of. Editors, a lot of people use a lot of different editors. Vim is one, Sublime is another, WebStorm and Atom. Those are sort of the most popular ones I hear over and over and over again. And it's kind of to each its own. That's always fun to talk about or interesting to talk about. I think Atom's kind of one of those up and comers. I haven't used it yet, but I think a lot of people are saying good things about it. But I think you kind of, in our group at least, it's probably pretty, Vim versus not Vim is what it boils down to, which is always funny. But those are the editors we use. I personally use Vim and Sublime. I'm kind of weird. If I'm doing Go backend code, I'll more than likely use Vim. If I'm doing front-end JavaScript React-y stuff, I will more than likely use Sublime. So that's kind of my breakdown. It's kind of a weird preference, but that's how I do it. It's just the tools I'm used to, I guess. From the server's perspective, we at Mattermost, I think, pretty much run Ubuntu 14.04 or 16.04. A lot of our customers and users we know run Ubuntu. And then probably the second biggest OS after Ubuntu is CentOS or even Red Hat. I kind of lump those into one, but basically CentOS. And then even though Docker's not necessarily a flavor, Docker's kind of the third thing, or Ubuntu on Docker is the third thing. So it's always kind of fun to talk about people's environments and what they use. There's a lot of great setup. I'm not going to go into detail about that. There's a lot of great setup instructions on how to get the environment set up. But yeah, that's a really high-level, quick overview of the Mattermost architecture. So.
Cool. We actually have a question from Nick. This is kind of pulling back to the web app stuff, but he's asking, are there any guidelines you've established for when to use state versus store in React?
Yeah, that's a really good question. I think if you look through a lot of our existing code, it's using state a lot, and a lot of our existing guidelines is kind of horrible to say this, but it's kind of like wherever it was easiest to put it. We didn't have a really good framework in place. I think what you'll see in the future going forward is being a lot better about that. Especially like I would look towards like the React native app where it's doing stuff in Redux. It's having an outside controller that's always kind of managing the state of the store, and it's just passing that down to its children via props. I think that's the model that we've kind of settled on, that everyone really kind of likes. The code base as it currently stands kind of has a mix mash of that. And we don't have any great guidelines, but I think the key thing to say is, our goal is to try to move away from state. And with that, that means moving more from straight to things like props, And in terms of storing things in the store as it exists today, we mainly store entities or stuff from the server in the store. Very little UI state is stored in the store. That sounded horrible. But we're hoping with things like Redux and the work we're doing there, that's going to change significantly. Where we're going to start storing a lot more of like view state in the stores themselves. It's something we're really keen on. It's something I think it's one of our the thing that people, I don't want to say hate the most, but we I think from our original implementations, we stored a lot of stuff in state, and I think basically the consensus is like we don't really like doing it like that. So the hope is over time, especially when we've done, especially once we've kind of proven Redux and the React Native stuff and start moving that back into the web app, the hope is to adopt that kind of model over time. So hope that answers the question.
Cool. Nick has a follow-up question. What's the timetable for Redux? And before you answer that, if any of our other viewers have questions, now's the time to ask.
The timetable for Redux in the React Native app is soon. I think the PR, the basis, or the sort of the root PR for that just went in. We're still having a lot of conversations internally about what that store looks like, how we want it to work. And so our hope is you'll see that in the React Native app within the next month or two. Like I said, the big PR for that kind of already went in. We're still reviewing it as a team. We've had a lot of discussions and feedback and talk about it, and everyone's, I think, really opinionated. And it's one of the things we really want to get done right, because we view the Redux store so some of our long-term, so it's interesting to talk about that. We view the Redux store and the client JSX file, or what we call the JavaScript driver, as our sort of all of that as our driver, and that's our offline storage and driver scenario. That's our caching scenario. Our long-term vision is that's just a separate repo, even that anyone can go and use the Redux store for Mattermost as well as our JavaScript driver and get data in and out of the system and store it offline or cache it locally however you want. And so that's we're trying really hard to be really clean about that model in the React Native experience. And then the goal is, once it's kind of proven and cleaned up there, start rolling that back into the web app and cleaning up the web app using that knowledge. And so the time frame is, the next 1 to 2 months for the React Native app, and you're probably talking 2 months after that or more before you start seeing some of that work rolling back into the web app. It's definitely one of our long-term visions. And by long-term, I mean 4 to 8 months out in terms of cleaning up a lot of that. I think cleaning up a lot of that, like I said, if you look at and it is what it is, but if you look at the state of the web app, I say it's Flux-ish because we did it at a time before Flux, then we kind of bolted on our variation of what we thought Flux was, and then now you have all these great frameworks in place to Redux that kind of really help you with that architecture or that framework. And so one of our definitely one of our long-term goals is bringing that back into the product, or back into the web app. Sorry.
Cool. I think that's all the questions we have. So if there's no other questions, so give it 10 seconds. We can end. Also, thanks, Nick, for all the questions. All right, that'll just about do it. Thanks, guys.